Hi, this is Dejie. I'm glad to share our recent work on ICCV'25, imitating human motions for visual robot manipulation with analogical reasoning. Visual robot manipulation enables robots' actions to follow language instructions based on states and visual observations, where the inputs include time step, language instruction, a sequence of visual observations and robot states, and the output is current robot action. The main challenge in VRM is the scarcity of robot data. To address this issue, some methods use general VLM data like VQA data about animals and diets for pre-training, which is hard to provide relevant VRM knowledge guidance, and some methods use human action videos for pre-training by contrastive learning in feature space, or predicting future frames in pixel level, which introduce irrelevant background information or pixel-level noise. To alleviate the limitations of the aforementioned methods, in this paper, we aim to imitating human motions for visual robot manipulation with analogical reasoning, which can learn relevant knowledge from human keypoints and avoid the noise. The contributions of our work can be summarized as 3 points. Firstly, we propose an approach that explicitly imitates human action keypoints from videos. Secondly, we propose the keypoint vision language model pre-training scheme to extract action knowledge from human videos, and analogical reasoning module to align robotic arms with human hand keypoints. Thirdly, our method achieves state-of-the-art performance on Kelvin benchmark and real-world robot experiments. And our framework contains 2 main stages: keypoint vision language model pre-train and analogical reasoning for robot fine-tuning. In keypoint vision language model pre-train, we use an egocentric dataset Ego4D with 3D hand pose estimations, which have similar tasks to VRM. At the timestamp we pre-train a keypoint VLM to predict the future keypoints, with the fused representations from human frames, language and previsions keypoints. In analogical reasoning for robot fine-tuning, firstly, we retrieve relevant human action videos that have similar history observations to the robot situation. Then, to bridge the gap between robotic arm and human, we propose an analogical reasoning map between the representations of robotic arm components and human hand keypoints to learn geometric and functional correlation. Thirdly, we employ a new linear layer on analogical representations for new robot states and compute MSE as the analogical reasoning loss. The overall fine-tuning loss is the weighted sum of the robot state loss by computing MSE loss with ground truth and predicted states, and the analogical reasoning loss. For experiments, we evaluate our method on a long horizon language condition benchmark, Kelvin. The Kelvin has about 4 different environments for evaluating the generalization of an approach, and it has 24 hours teleoperated data and 2 million episodes. The robot arm in Kelvin has 6 joints and 1 gripper. Our method outperforms all the baselines on multitask learning on Kelvin benchmark, and the results also show the generalization ability of our method across different scenes and unseen scenes on Kelvin benchmark. Moreover, our method achieves state-of-art performance on real-world experiments, including transportation and articulated manipulation. And we evaluate our method the data-efficient few-shot setting and unseen instruction generalization. We also achieve the SOTA performance on the 2 settings. The results show that analogical reasoning can help the robot's efficient few-shot learning, and human demonstrations can help the robot generalize to multiple new instructional tasks. We make ablation studies for our proposed modules. In the table, pre-train, retrieval, and R denote keypoint VLM pre-training with large-scale human data, retrieving human action videos for fine-tuning, and analogical reasoning, respectively. And the results indicate that keypoint VLM pre-training can learn human action knowledge from video explicitly. Retrieving human videos helps to maintain VRM knowledge and prevents the overfitting. Analogical reasoning shows the effectiveness of geometric and functional correlation learning. We also ablate the design choices of robot fine-tuning. The keypoint and VLM parameters are frozen or trainable. The best choice is to froze the keypoint parameters and train the VLM, which may be because VLM fine-tuning is critical for transferring human knowledge to robots, and stabilized keypoint features improves human-robot component alignment. The visual analysis, an example of our VRM result, and retrieved videos shows that our method can retrieve relevant human action videos such as pick up a tool, receipt, cloth, knife, from the database for robot imitating the human action of picking. We also visualize our analogical map and normalized analogical map partial example from hand keypoints to a robotic arm. The example shows the correlation between the estimated hand keypoints and visible robotic arm components. That is all. For more details, You can scan the QR codes of our project page and code repo.